Now, if you understand the ideal gas now, let's talk about how do we characterize any gas chemical physically. Okay, there are basically four things you should be looking at. Uh, for any gas, we're looking at pressure, temperature, volume, and one more. This is less related to these three. It's the number of mole or quantity of the gas. For let's go backwards. Okay, the mole is probably the easiest one. We understand it has a unit of mole, and it shows the quantity, how many molecule of gases you would have. So this is one of the major parameter you can describe any gas molecules. Okay, so it's mole. Volume is also easy to understand. Volume is basically typically used the unit of liter, okay, for gases, mole for mole, and it's determined by the distance between molecules. Only. Okay, so this is because of its ideal gas. The molecule itself has no volume, so it only depends on how far the molecules are. Temperature, so temperature is determined by the kinetic energy. Of everything we're looking at here, okay, we're looking at single molecules or speed, how fast the molecule is traveling. Okay, so in other words, if you feel some gas is really hot, that means the molecules are traveling at a relatively higher speed. Or if you feel something it's cold, that means the molecule there is kind of cooling off. They're not in high precipitation condition. They're kind of in not so much motion. This is not only for gas. This is for anything. Okay, liquid and solid as well. So temperature is direct reflection of the kinetic energy of the molecules, possibly atoms as well. Okay, and that's also showing that how much motion the molecules and the atoms are doing. In other words, at 0 Kelvin, which is so-called absolute zero degree, is because when you had absolute 0 degree, all the molecular level, at the molecular level, all the motions are completely seized down. So there's no temperature. Zero means there's no temperature. Okay, not even measurable, because there's no energy, zero kinetic energy for those molecules. The pressure is something kind of new. By the way, temperature we use Kelvin. Okay, for the units. Let me circle all the units for each parameter here. Pressure, usually we have several units. So let's take a look at the slides. Okay, this is something kind of new. Okay. Pressure, we have the most commonly used units is ATM. Okay, ATM is this abbreviation of atmosphere pressure, which can be measured by some other units as well: millimeter mercury, Pascal, and PSI, which stands for pound per square inch. Pressure is basically how much force at unit area. So these four units here: ATM, mercury, Pascal, and PSI are depends on the situation. Okay, I would say most popularly used pressure units is the ATM. Next to that, at least in chemistry, next to that is going to be a millimeter mercury. Here you won't know this. The millimeter mercury it's a combined unit of millimeter, which is the length, and the mercury, which is an element. Okay, so the height or the depth of the liquid density determines the pressure. So that's the reason why you have a length unit and the element symbol unit here, which representing this is using mercury, not water, because of the mercury has such a high density than water. And the other thing about the millimeter mercury is, which is completely exchangeable with another unit, which is called torr. Okay, so if we say 1 atm pressure is the same as 760 millimercury, that's equally saying is 760 torr. So without from now on, by default, you should recognize that millimeter mercury and the torr are completely the same thing, exchangeable. Okay. So if you want to, let's take a look at a quick example. How do we do unit conversion among these pressure units? So let's try one. Okay, I'm not going to do all of them. So let's say 28 psi. Are you able to convert psi into any other pressure units? Which should be very, very simple. Let's look at, let's say, if you have 28 psi and I want to convert this into ATM, and that would put psi down here and have the ATM on top here. And if we can go back to look at the number here is 1469. By the way, all these numbers are conversion factors. That means they are all exact numbers. So 1 ATM is 14.69. So you divide 28 by 14.69. Should give you a pretty crazy long number, okay? But this is a converting factor, so we don't recount fix. We only count fix of 28, which has 2, so we would have 1.9 ATM. Or you can convert this, keep converting this into, let's say, millimeter mercury. Okay, so can have the ATM down here. And this will be 1 ATM is 768 millimercury, so you'll find a fairly large number, but again you only have 2 sig figs, so you would be 1400 millimeter mercury. So nothing special here, just different units and with different converting factors compared to other unit conversion we have done before. Okay.